Bismillahirrahmanirrahim and Assalamu alaikum my dear students. I welcome you all to the lecture number 4 of electric circuit analysis. The topic of my lecture today is superposition theorem. If you recall, superposition theorem states that when we have to deal with more than one independent sources in our circuit, what we do is we turn on one independent source at a time and find the effect or the contribution of that source on the unknown parameter, and one by one this is how we turn on the independent sources. At a time only one independent source is on, however the rest of the independent sources are off. This is how superposition theorem works. So we'll start off with practice problem number 4.3. This states that we have to find V0. V0 is the voltage across 2 ohm. And in the circuit, this is the circuit we are given. Now if I'm confined to superposition theorem, then I know that I can see two independent sources. One is this 5 ampere current source and one is this 12 volt voltage source, and by superposition theorem I have to turn on one source at a time, however the rest of the sources will be turned off. So we have to find V0 is equal to, which is V2 ohm, and we have two independent sources. An independent source is always represented by a circular shape. So what I have to do is I have to find V01, which would be the effect of 5 ampere source, which is this, and then I have to find V02, which is the effect of this 12 volt voltage source. So with two sources we'll be having two simpler circuits. One source is on and the other source is off. So finding V01, what I do is I turn on the 5 ampere current source, however I turn off the voltage source, which is the 12 voltage source. Please remember that and recall that whenever we turn off a voltage source, it is replaced by a simple short circuit, or in easier words I can say a simple wired connection. The voltage drop across a simple wired connection is 0 volt. So by superposition theorem, while I turn on 5 ampere current source, I turn off this 12 volt voltage source, and doing so I replace this by short circuit. However the remaining circuit remains the same, and you can see that the circuit simplifies to this only one current source. These are, I have two resistors over here, 2 ohm, 3 ohm and a 5 ohm resistor. This current is being divided and flowing through two paths. One is this 5 ohm path and the other one is the 3 ohm and 2 ohm, and I have to find the voltage across this 2 ohm. So I told you this current is going to this node, and as soon as it enter this path, a node, it has two paths to traverse. The 5 ampere current is divided between this 5 ohm resistor and the combination, which is a series combination of this 2 ohm and 3 ohm. So if I sum up these, 2 plus 3 is 5 ohm, this is also 5 ohm. This means that this current is equally divided. This means I1 is equal to I2, which is 5 divided by 2, because half of the current is flowing here and half of the current is flowing here. I have to find I1, so it will be simply I1 is equal to I2. As I told you, if we have equal resistance on both sides, so 5 ampere divided by 2, this is 2.5 ampere. So each side, this means this side of the circuit is also getting 2.5 ampere, and this entire side is also getting 2.5 ampere current. So this is a simplified circuit. 2.5 going here, 2.5 ampere current going here, but actually I have to find the voltage across the 2 ohm resistor, which is by Ohm's law V is equal to IR. Here we have to find V01, I1 across the 2 ohm resistor. By just inserting values, I get to find that V01, due to the 3 ampere current, the voltage across the unknown resistor is 5 volt. Now we further go on to turning on the 12 volt voltage source, which is another independent source in the circuit. However, what we do is, as by superposition theorem, I'll now turn off the 5 ampere source. And recall that whenever we turn off a current source, it is always replaced by an open circuit. An open circuit means no connection. The connection has been totally broken up, hence the circuit becomes, this was the original circuit given to us in the question. I turn it off. When I turn it off, it is replaced by an open circuit because it was originally a current source. So this is how the circuit shapes up. Now further simplifying the circuit, what I get is I have one voltage source 12 volt that powers these three resistors, and these three resistors are in series to each other. And please remember that voltage across a series circuit is divided, however the current is the same. I is flowing through this, the same I is flowing through this, the same I is flowing through it. However, the voltage 12 volt will be divided among all of these. So by voltage divider rule, you know that the resistor across which the voltage is found, it is kept in the numerator, divided by sum of all the resistor multiplied by the applied voltage source. So what I get is 2 ohm is the resistor across which I have to find V02. This is the sum of all the 3 resistor in the series circuit, and the applied voltage source right now is 12 volt. By inserting values, I get to know that V02 is 2.4 volt. Now please remember that by superposition theorem, we have to find the individual contribution of each of the independent source, and finally in the end what we do is we sum up or add up all the individual contribution. V01 was due to the 3M due to the current source, and V02 is due to the 12 volt voltage source. I sum up these two, and what I get is V0, the voltage across the 2 ohm resistor because of the two sources, is 7.4 volt. So this is how we apply superposition theorem. I would recommend you to please go through example 4.5, which is very simple, and I left it for you to attempt. In case you have any problems, we'll discuss that in our online section. Please also go through exercise problem that I have mentioned over here, 4.8, 4.12, 4.13, 4.14, 15. And in case you find any problems in solving them, please do ask me in the question answer session regarding this lecture. I wish you best of luck. Stay safe, stay healthy, take care of yourself. See you in the next lecture. Take care, and Allah Hafiz.